Alright, so this is one of the examples from the textbook on parametric equations. So as you can see, we have x and y in terms of t, where x is t plus 1 over t, and y equals t minus 1 over t. And the problem is to find the derivative dy over dx. And so there are two ways to do this. The first way is to try to isolate, or is to try to get an equation with just x's and y's and to get rid of all of the t's. And so if we do x plus y, so x plus y equals t plus 1 over t plus y, which would be t minus 1 over t. And so x plus y simplifies to 2t because the 1 over t and minus 1 over t cancel. And if we were to do x minus y, we would get t plus 1 over t minus t minus 1 over t. And this would equal t minus t plus 1 over t minus a negative 1 over t, which would simplify to 2 over t. And so now this may look like it doesn't help much, but if we were to multiply these two equations here, x plus y and x minus y, we would be multiplying 2t and 2 over t, and as we can see, this simplifies to 4 because the t here and the t here cancel. And so if we simplify this, x plus y times x minus y, you get x squared plus xy minus xy minus y squared, which equals x squared minus y squared, and this equals 4, because it's the same thing. And so now we have this equation, x squared minus y squared equals 4, which is a manipulation of our original equation up here. And so now if we want to find the derivative of this equation, we take the derivative of each of the terms. So the derivative of x squared minus the derivative of y squared equals the derivative of 4. And so the derivative of x squared is 2x. The derivative of y squared would be 2y times dy over dx. And the derivative of any constant is 0. And now if we try to isolate dy over dx, we get 2x equals 2y times dy over dx. And if we divide each side by 2y, we get x over y equals dy over dx. But we aren't finished here because we want to substitute in our t's over here. And so we get the derivative is x over y, and x was given by the problem as t plus 1 over t, and y was given as t minus 1 over t. So the derivative dy over dx equals t plus 1 over t divided by t minus 1 over t. But if we want to clean this up a little bit, we can multiply the numerator and the denominator by t, so to get t squared plus 1 over t squared minus 1. And this would be our answer. Now this is the longer method. If we use chain rule as our second method, we know that dy over dx equals the derivative dy over dt divided by dx over dt, because in this case the dt and in the numerator and denominator would cancel. And so it's much easier to find dy over dt, and so let me rewrite our equations. X is t plus 1 over t, and y is t minus 1 over t. And so to find dx over dt, we take the derivative of both sides. And so we get, oh sorry, this is supposed to be with respect to t. No, with respect to x. So we get dx over dt equals 1 plus, and 1 over t is the same thing as t to the negative 1, so the derivative of 1 over t is negative 1 times t to the negative 2. So it's 1 minus 1 over t squared. And if we were to find dy over dt. We take the derivative of both sides of the y equation, with respect to t. And we get dy over dt equals 1, and now minus a negative 1 over t squared, which equals 1 plus 1 over t squared. And so now, using our chain rule, we know that dy over dx equals dy over dt divided by dx over dt, which is 1 plus 1 over t squared divided by 1 minus 1 over t squared by substituting from our dx over dt and dy over dt equations. And now to simplify this, we can multiply top and bottom by t squared to get t squared plus 1 divided by t squared minus 1. Now you notice this is the same exact answer as using method 1, except method 2 was a lot less work. And so we do that by using chain rule instead of solving for an equation without any t's in it.